Last time we had a look at the concept of properties, a way to represent data similar, at least from the outside, to a field, but that is internally just a neatly packed combination of getter and setter methods, or just one of the two at least. And we also had a look at a weird concept in C# and a lot of other languages, for that matter, where you can define a sort of contract that you apply to your own custom types, and that allows you to do some interesting things, like treating entirely different types, even mixtures of reference and value types, as the same thing, at least in regards to the contract they all agreed on. And today we're gonna play around with that concept a bit more. For that, we need some example code first. Let's say we have a player that's not going to do anything right now, and our player needs some equipment. So let's say we have a sword class, not sure what it does, but it exists, and we have let's say a shield, not shield class. Public class, let's say bow. For different types of equipment, maybe bracelet. And our player needs to be able to equip all of this stuff. Well, let's say we're not limiting the player to you can have one sword and one shield or one bow or something else, and just you can mix and match. You have different slots, different sizes, whatever, like one-handed, two-handed swords, stuff like that. So we have a number of slots the player is free for any type of equipment. And we could represent that with an array of some sort. That will be the equipment. And we saw last time how we can create a contract, public interface equipment, which is not going to have anything in it right now, just an interface as close to a custom type as we can get it right now. And all of our equipment types here will implement this contract, this interface. Just adding a colon after and the name. And this is now a system that the compiler will enforce. And so we can use it as a type to store equipment, but only in the context of what equipments are. In other words, the compiler allows us to store swords, shields, bows, and bracelets all in this one array, because they all fulfill the contract of equipment, even if the contract is entirely empty. So this is valid code. No issues with compiling, just fine. The only thing is that now this equipment can't do anything. The contract is empty, so there's nothing happening in here. Let's say we want to do something sensible. Let's do int get number of slots. Something like that. Simple method that calculates the number of slots needed for some equipment. If I now try to compile, the compiler will complain because these types say they fulfill the contract equipment, they implement that interface, but they didn't provide any specifications for how they handle this method that they all agreed to have. So we get a bunch of errors that we didn't implement the interface member. Member referring to just something inside a custom type. So fields are members, properties are members, methods are members. Everything that you put inside a custom type would be classified as a member. It's like a larger group that you put everything in. So we implement the method. I'm just too lazy to write that out. We'll do that like this. And it will return, let's say, 1 slot for the sword. And we can copy that over for the shield, which will occupy also 1 slot. Let's say the bow takes 2 slots. It's a two-handed thing. And the bracelet also only 1 slot. Like that. Now the compiler is happy again. We can store it. And it also means we can public... Let's make a constructor real quick. Public player... equipment... I can write equipment equals new I equipment, and we're gonna have, let's say, 5 slots. I'm not sure how that works on this game. Maybe the player has 5 hands or something. Who knows? And now we want method for public void equip, which will receive something like, for example, the sword. And we're supposed to store that internally. And let's also make a counter here, private and build slots. Build slots equals 0. So we start with 0 and then we go sort dot get number of slots. That's in slots. That's that. That's how many slots we would need for that sword, which would be 1, of course, because that's how we defined it. And then we can compare if equipment length minus build slots. This would give us the amount of total slots minus the slots that we already filled, so the number of free slots. If that is less than what we need, then we do something we learned about through new exception. No more free slots. And otherwise, we'll just put equipment build slots. I just realized the whole system here doesn't make too much sense, because I'm not actually... Oh, no, I could do that. Yeah, let's be fancy. Let's be fancy, because today is not gonna be a long episode anyway. Less than slots. Right, and then we go equipment I plus build slots equals sort, like that. We'll put the exact same object, the same sort, in all the slots it would occupy. And lastly, we're gonna build slots plus equals slots and that way we increase the amount of slots. Alright, so let's try that. We create a player. New player. Oop. And we create a sword. Sword equals new. We didn't create a constructor for the sword, but we don't need to. Default constructor. And then we do player dot equip sword. Doing that 1, 2, 3, 4, 5. Oh, right. Forgot. Using system. Let's try again. Did output nothing. Let's try that. Another sword. This is number 6. Exception, no more free slots. So that system seems to work. Let's try with a bow now. Bow. Bow. Equals new bow. Only the equip method doesn't allow for bows right now, only for swords. We could create a second method, but we don't need to, because both swords and bow fulfill the contract obligations for eye equipment, and this equip method only cares about the method that is already present in that contract. So we don't really need sword specifically. It's enough if we have eye equipment. Let's just switch the name to make it more readable, like that. The only thing we care about is this method, get number of slots, which is in that contract. So whatever we put into this method, whatever we pass on, has to be an equipment piece. Has to be something that accepted the contract eye equipment. And as such will have that method. The compiler will make sure that it exists. So there's no conflict here. We can pass swords in, just like before. No problem. But I can also put in a bow, which should overrun the 3 slots, yeah. Let's reduce 1 slot, and everything works again. So this is the primary use for interfaces, let's say. Well, not exactly primary use, but this is the more common use. You want to handle different types of objects, of things, the same way. And you do that by going for the common denominator, the contract they all fulfill. The things that are guaranteed that they all have, that the compiler will absolutely make sure of. As a side effect, we can also use that as a custom type for storage, like for an array, for example, or just for storing it as a single piece somewhere in a field. So if you create a linked list, you could do that. But the primary concern is we just want to mash them all together, all these different types, into one commonality that we care about. And as I mentioned last time, public void. But something like an attack method in sword, I won't have it in bow. I only have it in sword, so I can't do equipment.attack. That would work on a sword, but not on a bow or a bracelet or shield. Equipment does not contain the definition for attack. Equipment never said anything about attack. If we wanted to do that, we would have to cast this to a sword, specifically, which works as long as it is a sword. But once we pass on the bow, we get a bow internally, well, it doesn't work anymore. A bow is not a sword. So the attack doesn't work. in this one method, we only have equipment, so we can only do things equipment can do. Outside here, we have a sort, specifically sort. So there's no issue with calling a tag without any casting. Depending on where we are, we have to treat these values differently. The objects on the heap that they represent are different things, fundamentally different things. They just agreed that they all share a certain behavior through this contract. Something that annoys me about this specific implementation here, get number of slots is a pretty simple thing. Having to create a full method for that is a bit annoying. I feel like this could be a bit more elegant, but interfaces are locked to methods. That's all they can do. They can't define, you have to store this type of field or this type of data. That's beyond the scope of what interfaces are supposed to do. Interface cannot determine that a sword has to store a certain piece of data, or a shield, or a bow. That doesn't matter. How different types handle their own data, even if they have their data, if they have data at all, that's entirely up to them. Interfaces can only determine how I can use it. What are my options to actively do something with a type? What code exists or has to exist that I can call, that I can reliably call? So interfaces are locked to methods. Going back to last time, we talked about properties, which look like fields, but if you remember, properties are not necessarily fields. They can be tied to an actual field, to real data stored somewhere, but they can also represent something entirely different. A property is nothing more than a fancy way to have getter and setter look like a field. And since getter and setter are methods, properties are just methods or collection of methods. I mean, it's a getter or a setter, or maybe getter and a setter, so it's one or two methods. And as such, properties are allowed in an interface. We are allowed to define properties in our contract. So instead of making this a method, we can make this a property. Like so. Just like before with the method here, we don't add the body of the method. Too many? We just end it with a semicolon and leave it like that. We only define the signature. What does the method look like from the outside? And we do the same with the property that we define in interface. We have still the curly brackets here, just to define these are the property methods, which can be getter or a setter, or a getter and a setter. But instead of defining the body of these methods, we just end it with a semicolon. So we have either get or a set, or a get and a set. I mean, you could also do set, get, and the order doesn't really matter, but I don't think anyone is using that order. This is usually what you do. And we only care about the getting part, so this is how you find that in the interface. And since we have that in there, we can get rid of the get, make it a bit cleaner. Number of slots is now the property we demand of everything that implements our equipment. That means we have to switch this out. Instead of a method, we create another method. One. Just now the method is an property. Not an, property. And let's keep that up for the other types as well. Just copy and paste. This one was a 2. Like that. Oh, that's too much. Okay, number slots should be fine. And then we can change this up here as well. It looks like a field now. Even though internally it is... No, it is a method. Code works just fine. Now let's just copy, paste, and run. No free slots. The code still works as intended. Just now with a property defined in the interface instead of a method. Which is kind of the same, properties are just fancy looking methods. As now I could, instead of doing it like this, might look a bit better like that. But the downside here is, I mean, that works. But the downside is we don't really know what this property does. Properties are methods, so maybe it's as simple as return this constant value. But it could also be we have a series of complex calculations. There's a bit of a trade-off here, and if it's always the same value, maybe caching that value in a simple variable that you reuse all the time is more efficient in the long run. So, downside of properties, if you don't know what's happening inside, you might overwhelm the system by making some very unnecessary calls. But that's also up to the designers. If you define a class and a certain value is not as easy to generate or get, maybe keep that as a method and not as a property, just to make clear that something is happening. If it's a property, you're more likely to just use it. If it's a method, you might think twice as the user of that method and store the result and reuse that from a cache. Just a side note general for properties. Ooh, sorry. Was up late last night again. And with some friends drinking. Non-alcoholic. Had to drive. Interfaces. So, we have now this interface I equipment, which works. We can equip stuff. Nice. But a player will not always carry just their equipment. There will be more stuff they carry around. So let's say public class potion, like if they need to heal, or public class gemstone, maybe some valuables, some loot they can sell. Public class unidentified object. Maybe they found some mysterious thing that they need to identify. Or maybe it's a quest item, whatever. These are all things they carry around as well, but they don't equip it. So we're making another interface just to share all of these in one pod. Public interface, item, carryable. Maybe that's more clearer. Of course, it could be more playful, like I mentioned last time. Do something like I can be carried, right? But this is it carryable or is it carryable? I'm not sure right now. I should be. It should be the Y, right? Not IE. Not in this context. Let's keep it as is. If it's wrong, it's wrong. At least I'm only wrong on the internet. Nothing bad can happen from that. And variable, let's define a property right away, just like we did with equipment, and weight. Weight will have... No, it's a property, so just a property like that. Yep. And these will all be iCarryables. So iCarryable, this is iCarryable, and this is iCarryable. And so we need a property for all of them. And public int weight. Wait for it. Like that. Get return potion. Let's say potion is 5. Yep, like that. Too much. Once more. The gemstone. Let's say that's a bit lighter. That's only a 2. I should just make some space down here. This is getting too annoying. And the unidentifiable object. Unit. Public. Oh, let's make that private. Only int weight. And then put that in the constructor public. I'm not writing that out again. And weight. And then weight equals weight. Let's skip on the different checks for the proper values. Like we can't have infinite weight, we can't have negative weight. 0 weight might... Oh, actually, since an unidentified object, it might have 0 weight. Might be a mysterious object that floats, and you have to try to keep it down. There's a game I wanted to play on stream, actually. You should maybe put that out of the box at some point again. It has a weight mechanic internally, and most objects weigh. Some weigh quite a lot. But there are objects that can be lighter. Like you can catch butterflies, living butterflies, and they have negative weight. And your inventory is limited only by weight, not by amount. So strategy for that game is to just catch hundreds of butterflies to offset all the weight of the all other stuff you carry around. So you can have half a forest in terms of wood and logs and whatever in your inventory. And it's perfectly fine because all the butterflies help you carry it. So yeah, let's keep that in. Negative weight is allowed, so whatever, we don't care. And the player has now equipment, filled slots, and let's keep things simple, read only... Yeah, no, let's keep that as an array. Bag. And let's say bag puts new carryable, which has 100 free slots, whatever. And private int items. Items 0 to begin with, and then we can public void carry. We do exactly the same thing as we did with equipment. Carryable, equipment item. Maybe I should rename this to item after all, but the II looked weird. Huh. And if back.length is less than or equal to items. So if we have 100 slots and we have 100 items, well, then we are full. Throw new exception. Not enough backspace. And otherwise, back items plus equals item. Short one-liner. Remember, the post increment will mean we use the current value of items for wherever we put that, and the plus plus after is only carried out after we use the value. So for the first item we add, items will be 0, and the 0 is used for the index in the array back. And once we use that 0, we increment the value of items in the background to 1, or to items. So even though we address index 0, we also increment items to 1. So the next time we carry out this instruction, items will be 1 and we target index 1. A bit simpler since we don't care about the number of slots, we only care about the weight, which is a second thing we should have here. Oh, let's make this a constant. Just use more stuff we learned about the language. Public const int max carry weight. Carry weight. And let's say we can lift. I said a potion is 5. How much would that weigh? Let's say we are student adventure, we can carry 200. And we'll just have a quick method here, make our life a bit easier. Private int get current weight, and this will just for int e equals items -1. We'll do something a bit differently. This time we'll iterate from the top. I greater or equal to 0. That's I. And we'll have total 0. And then in here we go back I. Total plus equals like I dot weight. That and return total. Alright. Based on the number of items we have, we iterate through back. And we sum up all the different weights into total, which will return. And we can do that as well, not enough space. And if we have enough space, get current weight. We'll call that method to just store the current total. Like that. And just put that out into a separate method because we might want to use it in some other context later, and that makes this code a bit more readable since we don't have to worry about this for loop in between and the variables. current weight, and if current total plus item dot weight, if the added weight of this new item is greater than our max carry weight, then we throw another exception. This is what we're gonna do to simplify the process. Too heavy, like that. And we'll add the item as well. No, we can have... what did I say? What do we have? We have potion, potion seller, potion equals new potion, and maybe a gemstone or two. Gemstone, stone. Let's just call it gem. New gemstone. And then we can do player dot. Did I use store or carry? Carry. Carry, potion was fine, and player dot carry gem. And maybe you do that a couple of times for and I equals 0, I less than 100 plus I. We'll add 100 gemstones. Right, we should, if we do it this way, maybe it makes more sense to do it this way. Should have done that with the sword as well. Oh well. This should, if I don't add this, it should work. No? 165 doesn't exist. What did I miss? Oh, underscore was missing. Okay, that worked. But if I add the potion as well, too heavy. So our code is working. Let's see, 95 should be fine. Yes. I now have the option to carry equipment around, which I can equip, and I have the option to carry stuff around using carry. Thing is, now we'll get to the interesting part finally. Took long enough. Maybe I find an interesting sword or an old bracelet, and I'm fine with my current equipment. I don't want to equip the new stuff, but I don't want to throw it away either. Or maybe I do want equipment, but I don't want to throw away my old stuff, because I'd much rather sell it later. Which means that these equipment parts might also be something I put in my bag for storage. Well, that's a bit of an issue now. I have two interfaces. One that denotes stuff that I can equip and one that denotes stuff I can carry. Now I want some stuff to be available for both equipping and carrying. We could try to solve that by adding a third type of interface. And if something can only be equipped, it is pure equipment. If it can only be carried, it's pure items, pure carryables. And maybe a third thing for both equipable and carryable. And I would need a third list in here. And I would have to somewhat negotiate between the different lists whenever I add stuff that's only carryable, for example, or carryable and equipable. Maybe there's a shared list then between the two. Not ideal, but possible. Just a lot of work. There is an easier way though. Interfaces are just contracts you can apply to a specific custom type. It doesn't care about what other stuff that method does, or that class does, or struct, that type. Sort does its own thing. It has an attack method. I mean, it's empty, but it exists. Equipment doesn't care about that. The contract is fulfilled, and that's all that matters. Anything else in sort is completely irrelevant. And so there's the unidentified object. There's a field in here, and a special constructor for that field. How does it relate to iCarryable? iCarryable only asks that you have a weight property. That's it. What else is happening in unidentified object doesn't matter. So it stands to reason that if, let's say, a sort has not just another method, but also another property called weight, it shouldn't bother anything else, right? They should just compile and work, because it has no relation to our equipment. It's not bothering our contract, so why does it matter? Which means I could also do iCarryable now, since I have weight. I fulfill iCarryable. But I do want to use it as iEquipment. The simple answer is I can mix both. I just have to add a comma, and I can add another interface I want. This is a second contract I fulfill. These contracts are independent of one another. One doesn't affect the other. I can implement both interfaces. I can fulfill both contracts. I fulfill iEquipment using this property, and iCarryable using this property. Both contracts are fulfilled. There are no conflicts here. It just works. The compiler is happy. And so I can, instead of carry potion, also do carry sort. Let's maybe reduce it to 10 gemstones so we don't overrun our capacity. But this is perfectly fine now. A sort is iEquipment, but a sort is also iCarryable. I can pass a sort into equip because it fulfills the contract. I can pass it onto carry because it fulfills that contract. I can do both. I can do the same with shield and bow and bracelet. I can simply add a property weight. Let's say shield is a bit more heavy, 100. Bow. Bow could be a bit lighter, let's say 20. The bracelet is mixture between potion, let's say 4. Now all of these would fulfill iCarryable. I could take iCarryable and add that to all of them. All of these equipable things can also be carried in a bag. No problem. They fulfill all the contracts. I can also carry my bow. No problem here. But I can go even further. My equipment is always carryable right now. Doesn't matter what I have, all my equipment can be carried. Which makes sense if I can equip it. If I can hold it in my hand, I can carry it. It's kind of weird to have equipment that you can put on but not carry. I mean, not that it can't exist. It might be very special equipment, but for the most part, all my equipment is by default also carryable. And that's what I'm gonna assume for everything for now, unless I make a change later in my design. So I could take the property iCarryable from iCarryable and add that to equipment, because every piece of equipment can also be transported, carried. It will automatically have a weight. It has both number of slots and weight. Means I won't need the iCarryable anymore in here, right? Since the weight is now intrinsic part of the equipment already, no need to specify that with a separate contract. It's part of the equipment contract already. But the compiler doesn't like that. Technically, yes, we have that method. But now sort is iEquipment, not iCarryable. I can carry only iCarryables, only things that fulfill that contract. Yes, we know that technically everything that is iEquipment will fulfill the same idea, but not the same contract. It doesn't matter if it's the exact same thing they implement, it is still a different contract, and the contract is all the compiler cares about. The interface matters, not the content of the interface itself. The content will necessarily be the same if you have the same interface, but just having the same content doesn't automatically mean the compiler will allow it. There is a way we can achieve this, however, in a way that compiler is satisfied. And this might be the first time you get really weirded out by C#, and it's actually not that bad. I'm not really sure if you should be weirded out by that. Look, it's been so long, for me this is second nature, but I'm not sure what a fresh pair of eyes sees on this. Anyway, this interface is a contract, and we can say this contract has some prerequisites. To fulfill this contract, you also have to fulfill this other contract. You have to sign both of them. This interface implements iCarryable, as if this was a custom type that implements that interface, like Potion, for example. For interfaces, the meaning is slightly different though. We don't have to add a method for the property right now, for the weight. Since this is an interface, we don't have any implementation yet. It doesn't matter. What we mean here is that equipment requires you to also accept iCarryable. If anything is declared as I implement iEquipment, I am equipable, that means you also accept the terms proposed in iCarryable. You can't have one without the other. And now every sword and every bow is iEquipment, but inherently will also be iCarryable. The compiler ensures that whenever I have iEquipment, I have to have number of slots as determined in iEquipment and whatever iCarryable demands, which is in weight. If I leave out the weight, what just happened? Okay, we're back. If I leave out the weight, compile, I'm missing the weight. It's not part of equipment, it's part of this other contract. I careable. It's as if sort itself said I implement I careable. So I have to add the property. By the way, this is no problem. I can specify that I implement I careable. It's redundant. You already said so with iEquipment. To implement iEquipment, you have to implement I careable. It's part of that contract. So saying that again in here is unnecessary, but you can do that. It's up to you. Usually you would leave it out, but maybe it helps in your code. And sometimes it happens as part of refactoring. Like with us earlier, we had iCareable specifically in here to denote that our sorts are equipable and carryable, and then we decided to make equipment carryable by default. And we might have forgotten to remove that here. So that can happen. It's not an issue if you leave it in there, but it's redundant. Don't need to. So you can mix and match different interfaces. You could also go a different route, and if we want to have it separate, you could instead make one interface I both, like that, which in itself is empty. It offers nothing. It has requirements for equipment and carryable. And sort might implement both. Both itself doesn't have any requirements, whatever, but it brings with it the requirements iEquipment and iCareable. So even when you implement an interface, using another interface, you can still attach more interfaces and just join them. You can build this entire tree structure of interfaces that require other interfaces. You can't, by the way, make loops like this. It's similar how you can't store a struct inside of itself, or struct inside a struct that stores the first struct again. If you remember the whole thing of you can have a class that stores itself as a field, but you can't have a struct that stores itself as a field. Same idea here. You have this circular pattern. This thing, iEquipment requires iBoth, but iBoth requires iEquipment. These circles, they don't make sense. Don't do that. So, equipment is carryable. Oh, right. Forgot to change this back as well. Right, code is clean again. This is how I can combine different interfaces. Now let's get a bit more weird. This is the last thing we're gonna look at. I'm gonna make another interface. And what do I call this? Upgradable. Let's put it like this. Upgradable, and upgradable will coincidentally also have a number of slots. I imagine this like a system where you can add little gems, set them into your equipment, like the gemstones you find, and that will make your equipment stronger. Or maybe add enchantments or whatever. Like just upgrade slots that you can do fancy stuff with to improve your gear. And maybe this is a special sort. Swords can be upgraded. Well, this is an awkward situation. Sword now says, I fulfill the requirements for our equipment, and I carryable implicitly. and the ones for iUpgradable. iEquipment requires a property called number of slots that gets an integer. And iUpgradable requires a property called number of slots that gets an integer. And sort offers a property number of slots that get one integer. So it fulfills the requirements, right? What's the issue here? Well, the number of slots it requires in my inventory as a player and the number of slots it offers for upgrades are two different concepts. The interfaces determine a certain signature for our methods. In this case, a property, a special type of method, but still signatures for our methods that need to be present. And as long as that signature is fulfilled, we don't care about anything else, even if that same signature is required by an entirely different interface, which will likely have a completely different meaning. That's no problem. The compiler sees iEquipment is fulfilled, and iUpgradable is fulfilled. Everything is fine. So now I have number of slots, 1, which maybe is not that great if the number of upgradable spots is not 1, but maybe 0 for broken sword or an old sword, or 3 for a special sword. I want to have different number of slots for the upgrades and for how much they need of space in my equipment slots. The simplest, most straightforward solution is to use different names. Don't use the same signature. Use a different signature. I mean, that makes sense. And it's probably the better solution. Just use a better name. Number of slots could be a lot of things, and calling it required equipment slots and available upgrade slots are two different names that are slightly different, but also a lot clearer for the programmer that uses these types or interfaces. Sometimes, however, you won't have the luxury of renaming this, either because you're too lazy or because you don't have access to that code. You don't have control over it. Someone else created iEquipment, and maybe someone entirely else created iUpgradable, and you just get code from these two people, and you have to use what they give you. And there's no option for you to change anything in here. Shouldn't happen all too often, but it can happen. There's a way around this. We have to just tell the compiler that we have two properties. But we need to somehow specify that one of them is fulfilling iEquipment and one of them is fulfilling iUpgradable. If I add a second property here, still doesn't work with that hotkey, and just use that hotkey. If I do this, the compiler will complain, because I know I now have two properties with the same name. It doesn't work. Duplication, no good idea. We can, however, specify that one of them is for iEquipment. We use the interface we take it from as part of the name. This is not just number of slots, this is the iEquipment number of slots. And this is the iUpgradable number of slots. Now these two have a unique name. If you treat this as one name, it's as is. Usually you are not allowed to add a dot just anywhere in your members or variables or whatever. This is a special scenario. The dot has a special meaning. you can treat this as still one long text that denotes the name of this method. Or property specifically. The compiler understands that this dot is to separate the interface we took it from the name of the real property that we try to add in here, to implement. Thing is, with two different names, we don't have duplication of the name. We have two different names. We don't have duplicate definition for the member, and that should be fine. Except there's one little snag in here that's quick to fix. Public is not allowed, or private for that matter. If we implement that directly, specifically with the name of the interface we took it from, that tells the compiler we intend to explicitly implement this interface requirement. We fulfill a specific contract with this. One specific contract, not any contract, this one specific one. And since we already marked this as it is part of that contract, we also have automatically the requirement, okay, it needs to be public. That's what the interface is. If we fulfill the contract, we have to be as visible as that contract. We explicitly wanted that. We didn't just want a property that also fulfills the contract. No. This is exclusively for that contract. So it is public, and it returns an integer, and ta-da, we are suddenly capable of having two properties with the same name and overall signature, but for different things. So in terms of equipment, it needs one slot in the player equipment, but it offers maybe 3 slots for upgrades. And that works. Now, what you might be wondering is, if I now access sort.number of slots, which I seem to be able to do just fine. If I look at player, I only changed anything in here in sort. In player, the equipment still has just number of slots. I'm just calling the property number of slots, not equipment.iEquipment.number of slots. No, just equipment.number of slots. Which number of slots does it use? And the obvious answer should be this one. Because that's the one we care about. But why does it do that? If I just, let's get rid of some stuff here. No, let's keep that in. I'm just going to make a return here, so we skip that code. And I'm not sure if I want to reuse it, so let's get active. Console.writeLine slots, and we're going to do int slots equals. No, that's not what I wanted. Sort dot number of slots. So I'm calling that property, and we're just outputting the number of slots. Isn't that interesting? Sort does not contain a definition for number of slots. No, it definitely does. 2 of them even. I mean, we call it in the code here, and that worked just fine before. So clearly sort has number of slots we can call. What is going on here? Why can I sometimes call that property and get a value, and sometimes I get an exception because apparently I'm not capable of giving a number of slots?
if you didn't already guess it, which I assume 90% of you did, the secret here is that this number of slots does not ask a sort for number of slots. This method is not for sorts, it's for equipment. We ask some piece of equipment for a number of slots. Once we put an object in here, we only care about it in the context of you are a piece of equipment. And if we look at a sort from the perspective of you are a piece of equipment, we only care about the stuff that is part of this contract, this interface. And what in here is part of that contract? Well, we have the weight, which is definitely part of the contract, implicitly through carryable. Attack is not part of the contract, so we ignore it. Number of slots from iEquipment is part of the contract, explicitly. Number of slots from iUpgradable is not part of that contract, explicitly. So these two are all we see. Explicitly, these two properties are what we see in here for equipment. So this number of slots is predetermined to mean this. The compiler knows exactly what it is, because as far as the compiler is concerned, this doesn't exist and this doesn't exist. Up here, we don't look at a piece of equipment, we look at a sort. It has nothing to do with the interface. A sort is a sort, not an equipment. Yes, a sort is also a piece of equipment, we know that, but right now a sort is the custom type sort. And a sort has an attack. Sure, that's normal definition in here, it is there. Weight, it's just a normal property. Sure, it fulfills the requirements of an iCarryable, but it is still a normal property. Whether or not we have equipment up here, doesn't matter. It's just a normal property. We can remove it, and weight would still be just a normal property. The interface implementation is coincidental as far as the compiler is concerned. These two, however, these are special. These are not normal names. There's a dot in here with a name in front. These cannot exist in normal circumstances. This is otherwise an invalid name. This has to be special. It is an explicit implementation for an interface. So this thing only exists for iEquipment, in the context of iEquipment. And this only exists in the context of iUpgradable, only if we talk about something that is iUpgradable. These are not normal parts of the class. If you remove this up here, these don't make sense anymore. You explicitly implement the interface iEquipment, but that doesn't matter here. Sort is not an iEquipment. This is invalid now. Now it is valid, because we said we implement iEquipment, and this is code tied to this implementation. And this down here is code tied to this implementation. So even though it is inside that class in here, at this custom type, we marked it as, no, this is only for iEquipment, and this is only for iUpgradable. This is for sort. And weight is the special thing where it is both for sort, we can access it directly, it's a normal property, but it's also for iCarryable, well, iEquipment in this case, because it fulfills the contract. But this is a property of the sort first that fulfills the implementation requirements. This is the implementation only. It's simply placed in the same space as the other stuff. So up here, sort only sees the attack method. That's a fine thing to do. Wait. That's fine. And wait, these two are fine to use. Semicolon. Why can I not type? Please type. So this is okay. These are part of sort. If I want to use the specific number of slots, I can't use sort. I have to now do the opposite of what we did earlier down here, where I wanted to use the attack method of a sort even though I only have an equipment. I have to now cast this to iEquipment. And then I can get the number of slots of the sort. Specifically the equipment slots it would require. You can also do iUpgradable. And in this context, I request the number of slots this sort has to upgrade, which is a different property. Depending on how I view this sort, which is just one singular thing on the heap. There's only one object, one space on the heap that this addresses. It is the same address, but I look at it through the lens of the interface upgradable, which got to get a number of 3, or I look at it through iEquipment. I treat it as this is an iEquipment, in which case the return value would be 1. Or I would look at it as a sort, in which case it doesn't have the method or property. The same object can be looked at through different lenses in different ways, and depending on how you look at it, it will have different behavior. So it's not just about what something is, but it's also about how you use it, how you treat it. And so it can be necessary to take something that is an interface and cast it to its real type. Maybe I have to cast equipment to sort because I need to test something. But it might also be that I take a sort and specifically cast it to an interface because I need some specific implementation. It is not common, but it can happen. And it's important that you understand this specific feature, this explicit implementation. And it is usually only necessary if you have otherwise a conflict where two different contracts clash with what something specific should be. Unless, of course, the number of slots is coincidentally the same, in which case you can do it like wait and it would be fine. Oh. When you work with code like this, where you might have to cast, the difficult part might be to decide, can I do that? Maybe I do want to do something if the piece of equipment I get is a sword or shield. Maybe I want to do something specific, about only then. I get equipment, which has a number of slots, but I don't know what equipment it is. I can specifically cast to sword to attack or do something, but if it's not a sword, I would get an exception. But you can, of course, make it like we learned with try catch, then cast, and then catch the cast exception. You know it didn't work. But there are easier ways around this. Let's go back to this old code. Shouldn't have deleted the sort. That's better. Okay, compiles, it's valid code right now. Let's say I get a piece of equipment and now I want to do something specific if I get a sword. Maybe I want to play a sound effect. So what I can do, as I said, I could just try to sort equipment, sort, do it like this, store it as a variable sort, but only in the scope of this try. Just to make it easier, now I can do things like so dot right line equipping a sword with okay, I was tempted to now use the upgradable. Yeah, if it's a sword, then I can do with, let's do that, plus right slots. And then we do my upgradable sword dot number of slots, upgrade slots. And if it's not a sword, we just catch and we ignore whatever happens. We don't want special treatment for anything that's not a sword. So that worked. The bow would cause an arrow. Can do that as well. Console.write line equipping a not sword. There we go. Equipping a not sword, which is the bow we equipped in the end. This is a way we can deal with it. And instead of sword, we could also do it like this. Whoop. Equipment can also be directly casted to IO upgradable, because the thing beneath it is a sword. If this fails, we catch an exception, it's not a sword, but if this works, then that means equipment must be a sword, otherwise this cast would have failed. So when we reach this line, we know equipment is a sword. And so whatever equipment is, it can be cast to upgradable safely. We know it's a sword, and swords can be cast to upgradable. So we can cast equipment to upgradable directly. Doing it like this is a slight, well, it's a bit indirect, but, or not indirect, it's a bit unnecessary, but it would work. And it might make things a bit clearer to read. But writing a try-catch just for that is not a great idea. There are other ways to test it. We can, for example, sword equals equipment, and we learn about the first of two keywords. I can cast in different ways. I can cast with these normal brackets with the type I want to cast to, but I can also cast with a keyword, which I put after the variable I want to cast, and that keyword is as. Equipment as, and then followed by the type I want to cast it to. I don't want to cast equipment to sword. I want to use equipment as a sword. Try to treat equipment as sword and store that in this variable sword. Now this variable will either contain now a valid sword, or if equipment is a bow, for example, it will contain null. This, unlike a normal direct cast, explicit cast, will not throw an exception if the cast is not possible. It will try to cast whatever you have into the type you want, and if that's not possible, it will simply return a null. This is an operation, just like this down here. The difference is this will throw an exception, this will simply return null. So if sword not equals null, then we can do this. else we do that. Same behavior, just without a try catch. This is a safe way to cast. We can give it a try, and if it doesn't work, well, we can check for that, but nothing breaks. This is when you're not certain. And it's useful in a lot of different places. But for us specifically, things get even a bit easier. Because there's another keyword we can use, which has more users, but for us specifically, this keyword is let's do that. Same as with as. So equipment as sort. The other keyword is. Equipment is sort. This will not convert the variable directly into a sort. This instruction here will simply test, is it a sort? True or false? If this is true, then equipment is a sort, and we know we can safely cast it directly, explicitly, without worrying about any exceptions. And if it's not a sort, then this will hit. So we have direct cast, like this, which can throw exceptions. We have the value as type, the as keyword, which allows you to safely cast something if it's possible, and just give you a null if it's not possible, so you can test for it. And we have this is statement, which looks similar to the as, but it doesn't give you the cast value, it just gives you a true or false. Thing is a very powerful keyword, especially in the newer versions of C#. It can do a lot more, a lot. But even in the older versions, it had another trick. See, I said this doesn't cast. Well, that's only half truth. Technically, it does try to cast equipment into a sort, just like the as keyword does. Only as we have written it right now, it will only return true or false, depending on if that succeeded or not. If it did succeed, it will throw away the cast version. It will throw away the sort it casted equipment to, and just give us the end result if it worked or not. It's the combination of equipment as sort not equals null. We can trick the system a bit. Well, tricking is the wrong word, it's intentional behavior. We can tell the system to not throw away the sort if it worked, but keep it. Put that in a variable. And this might remind you a little of the way we handled ref and out in methods, when we had a reference parameter or an out parameter in methods, where when you call the method with a ref or out, or specifically when you call the method with an out, you were able to declare a new variable in the method call. It looked a bit weird, but something like method out int a. You remember that? We can do the same with the is keyword. I can declare a new variable. Equipment is sort will still check if equipment is a sort. And this whole thing will still return a true or false, depending on if it is or not. But if it is, well, the result will be kept inside this variable sort. And in terms of scope, this is part of this method now. It's on the same scope as the if statement. So it's not localized internally into just this block. Sort is available now. just sort might be null. If sort not equals null, then sort dot attack. For example, let's do something. Console dot write line attacking. Let's try to run this. Oh, right. My bad. Not now in this context. I got this. Yeah, that makes sense. Sort is not null. Sort might be unassigned. That's different from the as. Sometimes I forget stuff, and I probably shouldn't talk about these things in the last minute if I didn't prepare and check beforehand. Alright. So the problem was, if it is a sort, this will be filled with sort. If it's not a sort, this variable will be uninitialized. No value. So if I wanted to do that, I would need to be very sure that it is null by explicitly setting it to null. Okay, that's better. This is not like a try method where you have a try cast or something, where you get a boolean back and the out value is either a default value or the proper value. Is will either initialize it or not, depending on if it's possible. But yeah. We have direct casting. Or let's try it in the context. We have either direct casting, equipment, or we have equipment as sort, which is a more safe version, or we have equipment is sort, which is a true or false statement, but can store the result if it is a sort. These are the different ways we can cast data in different types. This applies to all casting, by the way. This is not just for your custom types. This applies to everything, but once you work with custom types and have these different interfaces and they all are combined and interlocked and whatnot, this becomes very important. Depending on the context, you need the data to be treated as a different type. And so you need to cast it into a different type to get that different behavior. In equipment, we care about it as equipment, but we might care about it being a sort and having some additional stuff. Or we get a sort, but might want to look at it as a specific interface, like equipment, so we can get a specific property that's otherwise hidden if it's only the normal type. And that's where we're gonna leave off for today. And with all of this stuff, we are, I think, equipped for next episode where we get into the real fun part. I think a lot of you will know where this is going next week. Alright, have a lovely Sunday, and until then, goodbye.